Hello students, today we will do vectors and their components. But first I will request all of you, please do share my channel, please do like my channel and please do subscribe my channel so that can enthusiast me more to make you more learn about the physics, what I know to convey to your brain. Thank you very much. Let's start vectors. Vectors and their components. Today this is our subject. So what in our previous classes, maybe in class 9 or 10, you may have known the physical quantities, all are vectors, some are scalars. So a vector has a magnitude. We know that, everyone will know. Along with this, it has a direction. So it has a magnitude, it has a direction. So whatever may be, we draw like this from point A to point B. It's a displacement. So any displacement is a vector. Displacement is a vector. Always keep in mind, displacement is a vector quantity. So displacement is a vector quantity. So these are the theories. Most of the terms we have ever about in class in our 9 or 10, whatever may be. So this is a vector from point A to point B, the displacement. So it's a vector because it's got a direction as well as a magnitude. This magnitude is a displacement magnitude. Fine. Now a point can move from A to B. It can move to another point also, another place also. So some theories later on came like this way, adding vectors geometrically. We also added here geometry, a straight line. Geometrically. How? It starts from this point. Keep in mind, it starts from this point. It starts like this. So A, this point is at B. Again, the displacement goes like this. So this is point C. Geometrically, we have to add like this head-tail formula. This is tail-head formula or head-tail formula. So we will add from A to C like this. So this is head, this is tail, head-tail formula. So net displacement, this is net displacement, net displacement. Net displacement is the vector sum. Vector sum. Now, like this, again drawing the same part. This is A, this is B, this is C. We have added like this. So if this vector is this vector is this, so the summation, these are all vectors. So this, like if it is C, so C will C, this is the resulting vector, resultant vector. C is the resulting vector from tail to A. The C is the resulting vector. This is the resulting vector. From tail, as I told you earlier also, head tail formula from tail A, from sirf what we did here, the notations of vector A and vector B and vector C. From tail of vector A to head of vector B. So from the geometrical when we add, the summation will be like this. The vector A to head and tail. This is tail, this is head of B. This is head, this is tail, goes like this, we added like this. So this is the vector geometrically addition, geometrically vector adding formula. So we can write to C is equal to vector A plus vector B. Again, from here, what we can do, like previous, as we did like this way, what we did this. We can do what, like this, parallel for addition, and we what can do from here to add this. This can be also done. So if this is a start and if this is a finish, so again it's a vector A and it's a vector B. Again, this is parallel. We know by the theory of parallelogram, this is vector B and this is vector A. So what we can say, the scenario will be vector A plus vector B is equal to similarly vector B plus vector A. In the mathematically, we know this is called commutative. This is commutative law. So vector can be represented in commutative law also. And again, this vector can be also done by associative law also. So if we add like this way, so this will be A, vector A plus vector B, as we know from here. This is vector B, and this one is done B plus A. For this part, B plus A, we know. Now it can be done in associative law also. How? Again, if this is a vector A and this is a vector, this is a vector A, this is B plus C. So this vector will be vector A plus vector B plus vector C. So by the law of associative, A vector plus B vector plus C vector can be said A vector plus B plus C vector. This is associative law. Associative law. Mathematically, we can know this. Now we'll learn components of a vector. Components of a vector. Component of vector, what is this? Actually, component of vector is the projection of the vector on an axis. Projection of a vector on an axis. So if this is x and y, if this is origin and this is x and this is y, so this vector, what the components ax and this is ay. If I made a virtual like this point, and if a vector starts from this, drawing like this way. So this is origin, this is ax component, this is ay component of the vector, this making an angle theta. So this can be done also in separate way, just I'm telling you, like this. If this is origin, this is x, and what we do, like this is y direction, this component is ay and this component is ax as usual, but again it will be start from here, let it be that this is a vector a. So we may draw like this and we draw like this. So if this is the scenario, what we can do, this and this we can add. So this part will be again making an angle theta as we know earlier. So these are the component vector. This is the x component of the vector, this is the x component of the vector, x component of the vector. Okay, so these are the x component vector and this is y component of the vector. This is y component of the vector, y component of the vector. So these are the scenario. Now finding the components. We can find the components of vector A from this figure. What we can understand, if we just take this figure, from this figure if we shift the vector like this way, so the geometrically from the right triangle there, a right triangle is there. So a right triangle is there. What right triangle is there? Geometrically a right triangle will be there. So this will be the right triangle. So as we know earlier, so this is the scenario will create like this. This is the right triangle is created. So this is, if this is ay, if this is a, so this is xy, so this is theta, and this is right angle will be created. So x component ax will be what? A cos theta, and ay will be a sin theta. So these are the component of vectors. So these are the very important. So how we can break the vectors of the x component and the vectors of the y components in the, so ax is equal to a cos theta if the angle is theta between these two, vector a and the x component, and the ay will be a sin theta. Now these are the components of the vector. Now we will learn unit vectors. Unit vectors, as we know, x, y, z, these are the three part, three dimension. This is x, this is y, and this is z. So in vector generally we signify with, this is with I cap. Similarly, this is signify the y part, the j cap, and this is z with k cap. So we signify this x, y, z with I, j, k. Always keep it in mind. So when a vector A will write like so, what we can write like ax I cap plus ay z cap, x, I and j. So xy. Similarly, we can write b, vector b is equal to bx I cap plus by j cap. So these are the formation to write the unit vectors. Now again, as from this picture we can draw again this, what you learn y, what you learn x. Okay, so these are the components. So what we have written here, ay, so we can write ay, what we know, ay is with the z, z, this is ax, it will be with I. So I think now you can get it. So if we shift like this, so if this is theta, so vector this a, so we can x vector, this is the x vector, this is the x vector component, x vector component, this is y vector component, y vector component. Got it, student? Now we'll learn adding vectors by component. Vectors by component. Unit vector, what will unit vectors I, j and k have the magnitude of unity, obviously, and directed along with the positive directions. So far what we have learned like this from this picture. Okay, if I, j and k, from this picture we can see. So the vector we got ax, ay and az. So vector a will be like ax I, ay j plus az k, adding vectors by component. So we can understand these are the situation. From this picture we can add with the components from vector a. These are the parts. If we add this, we will get this. Again, as a resultant part, as a resultant vector, what you will add the resultant? If it signifies like rx is equal to ax plus bx, ry ay plus by, rz will be az plus bz. So these are the situation by adding vectors we will get from this. Now the procedures for adding vectors by components also applies to vector subtractions also. So it will be applied in vector subtractions also, So if the displacement, the subtraction, so if we denote d is vector a minus vector b, because subtractions we are denoting with d. So again, from the associative law, from the commutative law, so what this D we can be implemented like this: A plus minus B. This is the situation. To subtract, we add vector B. To subtract, we add vector A and minus B by components to get. So what we'll get? Dx is equal to Ax minus Bx, like 1, 2, 3. A. Similarly, from this, like 1a, so dy will be ay minus by, 2a, and dz will be az minus bz, so it will be 3. So these are the situation we can get from the subtraction. So from like this, from this as addition, so d vector will be dxi plus dyj plus dzk b. So these are the situation we'll get by adding this. So this will add, will get, if we add like dx plus dy plus dz, so we'll get like this. So these are the situation will by getting subtraction of vectors by component.